Hey everyone, it's Actuary Dude here. So let's have a look at some more maths, actuarial maths at that. So let's say we've got t being time, and we start at time 0, and we've got time period 1, 2, 3, 4, 5, 6. And at each of these time periods, except for 0, which is now, we receive $1. So there are $6 going around at the end of each year. So I guess some would find this familiar as an immediate annuity. Now, I want to know what the present value of all of this is. So if someone said to me, hey, do you want $1 each year for the next 6 years? Is it maybe I should take $6 right now if I get the chance? So let's see what happens. Let's discount this $1 back, and in order to do that, we'll make a factor v, and that's going to be 1 divided by 1 plus I, and so that bit over there is what we're going to use to discount this dollar. So we're going to have v, and then we're going to add this dollar in 2 years' time. So we're just going to have to discount it back 2 years, because 1 divided by that squared. Yeah, that's how it works. Plus, we're going to have v cubed, v4, v5, and v6. Now, this is kind of annoying to figure out, especially if you don't have a calculator. So, what's the best thing to do? So, for me, personally, what I would do, or at least what's been done, is people identify this as being the sum of a geometric series, or sequence, where you essentially, the ratio that's changing here is v, so we can see it's going up by v each time. So let's just label this one equation number 1. Let's also multiply it by a factor of v again to get equation number 2, which is going to be v times the present value is equal to, and then all of these things will be multiplied by v. So that'll be v squared, v cubed, v to the 4, 5, 6, and of course 7. So they all went up by 1. Now, these are both equal, because if we just divide all of these by v, you'll get the same thing over here. So it's the exact same thing. So what should we do? Let's try and take equation 1 and minus equation 2, just for the fun of it, to see what happens. So we'll get the present value minus v times the present value is equal to, and then we'll start off with v plus v squared, and so on. Now the point of this video is to write it all out the way that I am doing, even though you can probably see a pattern and think, okay, I don't know why it needs to all be written down. And then we're going to minus all of these. So we're going to minus v squared, minus v cubed, minus v4, v5, v6, and v7. And of course we notice that v squared minus v squared and v cubed minus v cubed, they all cancel out. So we'll just do that because we can, to make things simpler. And so then, if we also factorize this bit, and we take out the present value as being a factor, and we leave 1 minus v in the brackets, we then also get, so that's going to be v minus v to the 7. Okay? Now, all we have to do is get the present value by itself, because that's what we're trying to solve, and in the simplest way. So, what can we do? Well, let's also factorize this, just because we can. And let's bring out one of the v's, so it'll look like that. And we're going to have the present value is equal to, and then we're going to divide this by 1 minus v. Okay, now it's kind of looking pretty close to what we've seen being an annuity formula, but it's not quite there. Even though in fact you can use this as this, I mean, this still works for an annuity formula, you've just got to know what things to use. So I mean, we identify that this is d, so if they gave you, say on an exam, this is v, this is d, find out what the annuity is, and this is n, then you're pretty good. But let's just continue it. So let's separate this bit, and we'll make these two equations. We're going to have v, sorry, not two equations, two expressions, because it's going to be v on 1 minus v multiplied by 1 minus v to the power of 6 divided by, well, 1. And what is this? Well, in fact, this is I, and we'll see that. So it's going to be 1 on 1 plus I divided by, this will be 1, so instead of writing 1 I'm just going to do 1 plus I on 1 plus I, and then it's going to be minus 1 on 1 plus I. And it so happens that those two cancel out, so you get something like this. So we're going to have I on 1 plus I inside from those brackets is there, and then we've also got 1 on 1 plus I, and that's divided. When you divide, so we've got this, then we times it by 1 on 1 plus I to the I because we flipped that, and so then these two cancel out and it just becomes 1 on I. So if we write it, I'll just write that there. So if we now change this and call it 1 on I, sorry, this isn't I, it's actually equal to I to the negative 1, or 1 on I, multiplied by 1 minus v to the 6 on 1. And so that then equals 1 on v to the 6 divided by I, which we happen to know looks something like that. So if we just replace this, the ends, then we're pretty good. So we haven't, I guess, essentially proven anything, but we've derived it. So we have derived the immediate annuity formula, and that's how it's worked out. Just to show you that all of these numbers here, one's discounted back, so all of these just can be written down in a pretty simple formula like that. Very good. Thanks for watching. Actuary Dude telling you that it's cool to be an actuary.